Okay, good morning class. So today we're looking at the grade 11 paper 1, November 2016, the TLC paper. Okay, Leadership College paper. So the first question says, solve for x. For x is an element of real numbers. Okay. Let's go. In 1.1, we've got x squared minus 4x plus equals 12. So firstly we bring that 12 over the equal sign to get the equal quadratic in the standard form of ax squared plus bx plus c equals 0. So it will be 4x minus 12 equals 0. You can factorize using your trinomial factorization. 6 and 2 minus plus. So x is equal to 6 or x is equal to minus 12. If you prefer using the quadratic formula, no problem. Okay? If you always having a problem with signs or sometimes not getting the right to do so, any of those there, you can, as I said, use the quadratic formula. Okay. Let's carry on. In 1.2, the question again says solve for x. We carry on. So you divide by 3 first to isolate the base there. So 5 to the x equal to 25. 25 can be written as 5 squared, therefore x is equal to 2. Remember, when bases are the same, the exponents are equal. The next question says, in 1.3, you see when it says correct one decimal digit, then we know you must use the quadratic formula. So in 1.3, you got x is equal to minus b plus minus the square root of b squared minus 4ac over 2a. The question is 5x squared minus 6x minus 15 is equal to 0. Now my a value of course is 5, my b value is negative 6, and my c value is negative 15. Remember that the sign is part of the term. So x is equal to minus 6 plus minus the square root of negative 6 squared minus 4. My a is 5 and c is negative 15. And this is all over 2a, which is 5. We know we're going to have two values here, unless the roots are irrational. Not irrational, but non-real. So that is going to give us 6 plus the square root of 6 squared, or negative 6 squared, minus 4 times a times c over 2a. Okay. So that gives us 2 comma 4 3. Okay, on the other hand, we replace that minus plus with a minus. That gives you an answer of negative 1 comma 2 3. Okay, otherwise we have the grey calculator, you can go straight into it. We just say shift, program it, it gets 5 for A, negative 6 for B, negative 15 for C. However, that's correct, yeah. However, if you go, for this question in particular, there's 4 marks on the sub. 2 marks is awarded for substituting the formula. Okay, you can show the substitution and then the other 2 marks in the solution. Yes, ma'am. 1 decimal place. Right? So this is going to be 2.4. And I would have lost 1 mark because I'm not adhering to the instruction. Okay. Thank you, Aaron. People 1.4, by completing the square, leave your answer in third form. So as we know, you're going to first divide by 3. So what do I get? X squared plus 8 over 3x plus a number to complete the square with equals 4 over 3 plus that same number. If we're adding on the left hand side, it's adding on the right hand side to balance the equation. Okay. So what must be added here? It's going to be b times a half, which is 8 over 3 times a half is 4 over 3, and it must be squared, which is 16 over 9. Alright. And of course, on my left hand side, I got a perfect square trinomial. So it's x plus 4 over 3 squared equals, that's over 9. 3 times 2 is 12, it's 28 over 9. Is that correct? Square root both sides, do not forget. Plus minus, so x is equal to minus 4 over 3 plus minus the square root of 28 over 3. Which now can be written as minus 4 plus minus the square root of 28. Over. Is that correct? Any confusion there? Please know how to do this completing of the square. Okay. Especially when that question come about maxima and minima and stuff like that. You need to know how to complete the square. That question was asked in the grade 12 paper as well, not paper 2. Maxima and minima, where the people need to complete it. They could have completed the square or derivatives. No, sorry, paper 1, paper 1. And you guys had that question often as well. Huh? P1 Nov, a definite question you must get, your inequalities. So you got x squared plus 5x minus 6 is greater than 0. This factorizes into x and x, 6 and 1, plus 6 minus. So you got critical values, yes? Oh, it's less than 0, no problem. So you got that. Do not say x is equal to negative 6, or x equal to 1. You will lose them all three. Otherwise, you will claim solutions there. So it's got negative 6 and 1. Less than 0 means to say it must be below the line, not so. So it continues or breaking solution? Continuous. So it must be written together. The inequalities will always go in this direction. Okay? So we're saying that x must be greater than negative 6. And x must be less than 1. Okay. Look at 1.6 and 1.6. Another inequality. However, what you notice here is that 3x is always positive. Not so. If I draw the 3x graph, this is 1. What do you notice? It's always positive. But now you see that is greater than 0. What does greater than 0 mean? Positive. So, that product is only dependent on that number being positive. Not so? And when is that positive? It's positive when 5 minus x is greater or equal to 0. So you just solve for x. So minus x is greater or equal to minus 5. Divided by negative, what's going to happen to the inequality? Switches. So x has to be less than or equal to 5. Okay. Okay, so here we are told that solve for k. Okay. So 1.7.1, we've got k minus 1 plus k over k plus 2 equals 5. What's my LCM here? LCM k plus 2. What's my restriction? K can never be equal to negative. Okay. So naturally this is over 1 people, that must be multiplied by k plus 2. That must be multiplied by 1, and that must be multiplied by k plus 2. So you got k minus 1 into k plus 2. Plus 15 times 1 equals 5 into k plus 2. Now it becomes an equation to us, which gives me k squared plus k minus 2 plus 15 equals 5k plus 10. Okay? Bring everything to one side, we can give you k squared minus 4k plus 3 is equal to 0. You all agree with that? Got k and k, 3 and 1. Both is negative. So k is equal to 3 or k is equal to 1. It doesn't interfere with our restriction. Okay? You all agree with that? Did I send you that the memo of that other paper that? Yes. Okay. Thanks again. To Aaron. Whoever's phone is that? Please put it on silent. Okay, so what do we note here in 1.7.2, we see that it says hence. If it says hence, what does that mean? Let's use the previous solution. Hence, solve for x. So what we notice is that on k's place, we got 2x squared minus x. Can you see that? There's the minus 1. There's the 15 plus 15. On k's place, again we got 2x squared minus x plus 2 equals 5. Did you see that, people? So what do we say? We can say that k is actually equal to 2x squared minus x. Because now, what is k from the previous solution? 3. So 2x squared minus x equal to 3, or 2x squared minus x is equal to 1. Becomes an equation again. So 2x quadratic equation. 2x squared minus x minus 3 is equal to 0. Trinomial 2x, x, 3, 1. So it will be minus and plus. So x equal to 3 over 2, or x equal to negative 1. And then we take this 1 over, becomes 2x squared minus x minus 1 is equal to 0. This also factorizes into 2x, x, 1 and 1, is that correct? That's minus and plus, so x is equal to negative half, or x equal to 1. Okay, you all agree with that? You know, that is a lot of work for 3 marks. One I know, when you made that link here, then I gave you one on each set. I gave them one on each set of solutions. Even question 2, also a definite question, you must get 0 simultaneous equation. Okay. And we also know at this point that most of the time, if not all the time, other than the question where they say to 2 decimal places, everything else, all the other equations, works out to be nice rational numbers. So if you come to the simultaneous equation and you see you need to work out the quadratic formula and it's the 2 decimal places, know there's something wrong. Okay? So most of the time it's only that one question where you have to apply the quadratic formula that is actually to 2 decimal places. The rest of the numbers, most of the time, as I'm trying to emphasize, will come to be integer values. Okay? So let's go here. We take it over the equal sign, so it becomes x is equal to 2y plus 1. So what do we do with this equation? Wherever we see an x, we replace x with 2y plus 1. So that becomes 2y plus 1 squared plus y squared is equal to 9 plus 2y times x, which is 2y plus 1. Don't put the y at the back and say you got 2 into 2y plus 1 y. So many a time people multiply that out, they get 4y plus 2, and then the y they just put down there. But it's actually the 2 and the y that must be multiplied. Okay. So no other. Just need to line the board again. Alright, so let's go. Let's see what we get. We got 4y squared plus 4y plus 1. People, again, if you can't do this binomial squared in your head, you can't do it in your head, write it out twice and multiply. Plus y squared equals 9 plus 4y squared plus 2y. Okay, so what happens is that will cancel. So we've got y squared plus, we're setting up a quadratic equation here. So that's going to give you plus 2y minus 8 is equal to 0. Again, trinomial, people, if you can't use the can't factorize, use the quadratic formula. Okay. So y is equal to, why is this doing this number? So you got y is equal to negative 4 or y is equal to 2. You all agree with that? Then from here we need to calculate your x value as well. Okay. So what we do with that is we plug it into that equation there. So x is equal to 2 times negative 4 plus 1, which is negative 7. Or x is equal to 2 times 2 plus 1, which is 5. Okay. And there is ways and means of checking if you're correct. You substitute it into the second equation there, the bigger one, and see if the equation balances if needed. Okay. The next question. People, nature of roots, very important. No? I see some of you are lacking in this section of work here. Please don't go into paper 1 without knowing this one. Okay. It says show that the equation x squared plus kx plus k squared plus 2 equals 0 has no real roots. People, if it says no real roots, what do we know about delta here? Delta must be negative. Okay. Show that the equation. So this is a show that question. Okay. So we can't use the fact that delta is less than 0. We are actually going to prove that delta is less than 0. Okay. So if you're looking at this here, my coefficient of x squared, which is a, is 1. Coefficient of x, which is of b, which is k, and all the constants, the terms out the variable will be c. Okay. So as we said, delta is equal to b squared minus 4ac. So your b value is k, so it's k squared minus 4, a is 1, and c is k squared plus 2. Get rid of the bracket. So it's going to be k squared minus 4k squared minus 8. Okay, so it's negative 3k squared minus 8. So what do we notice here? This graph will have a maximum or minimum value. And it's negative, so it will have a maximum. Not so. So if I had to draw this graph, the graph will look something like that. Can you see? This is now your delta, and this is your cables now. Alright? So what do we notice? We notice that delta will always be negative. Can you see it? Delta will always be negative. So we say since delta has a maximum value of negative 8, therefore roots will always be non-real for all real values of k. Can you see that, people? Alright. The next question is 2.3. Question 2.3 says simplify without the use of a calculator. So I know most of you use a calculator anyway. You will be penalized. So what we do is we need you to do the following. 8 can be written as 4 times 2. The 50 can be written as 25 times 2. We write the biggest perfect square that can be divided into those numbers. The denominator, that's a conjugate pair. You multiply the first and the last. So it's 1 minus root 2 times root 2 is 2. So the square root of 4 is 2, and that 2 times this 2 is 4. So it's 4 root 2 minus the square root of 25 is 5. Root 2 over negative 1. Okay. 4 minus 5 is negative 1, so 4 root 2 minus 5 root 2 is negative root 2 over negative 1, which is square root of 2. Okay. Next one. As you can see here, we multiply, we base the same, and we multiply, we add the exponents. So we break these numbers up into products of its prime factors. So 15 can be written as 3 times 5 raised to the x times 3 to the x all over. 9 can be written as 3 squared raised to the x plus 1 times 5 to the x minus 2. Here at the brackets, so it's going to be 3, there's a 1 on each. So it's going to be 1 times x is x times 5 to the x times 3 to the x all over. We multiply that exponent, it's going to be 3 to the 2x plus 2 times 5 to the x minus 2. When we're multiplying and bases are the same, we add the powers. When we subtract, and when we divide, we subtract the exponents. So it's 3 to the x plus x minus 2x minus 2 times 5. Now those bases are going to be brought together again. And those exponents, sorry. So it's x. We're dividing, we subtract the exponents. It's minus x plus 2. As you see, the signs are changing. So it will be 3, the x is cancelled, to the negative 2 times. 5, the x is cancelled, squared. 5 squared is 25. And 3 to the minus 2 is going to be 1, it's going to be 3 to the 2 in the denominator, which is 9 there. So it's 25 over 9. Alright. Let's carry on to the next one. This one's a bit different. There's a plus or minus between. If there's a plus or minus, what do we do? Break up and factorize. Okay. Anika, what you busy? It doesn't look like you did this work. Am I right or wrong? You did it. But you're not looking here even. Okay. So this is a plus or minus between it. So what do? We break up and factorize. So that basically going to break up. That's already in the form we wanted. You don't have to break it up. When you that kind of girl, the one to come between, families and stuff. Right, that you can play it like it is. Okay. But there's no mark allocated if you break it up. Okay. Now, I know some of you can see that 5 to the x is common. Then we left with 5 squared minus 4 over. 5 to the x is common in the denominator as well, so it's 2 times 5 to the minus 1 plus. Often that 1 gets forgotten about, okay, so watch out for that. That cancels, of course, so 5 squared is 25, minus 4 is 21, over 2 over 5 plus 1. So it's 21 divided by, we've got an LCM here of 5, so it's going to be 2 plus 5, which is 7. That's over 1, so it's going to be 21 over 1 multiplied by 5 over 7. That goes 3 times, so the answer is 15. Okay. From here, I would have, you go from there, plug it in the calculator and get that answer there. I would have given you, in this case, a full 3 marks anyway. Okay. The next question is solve for x. Okay, a lot of term 1 were coming in here. Solve for x here, as we know, we need to break that up there. So that can be written as 2 to the 2x times 2 cubed minus 10 times 2 to the x plus 2 is equal to 0. That can be written as 2 to the x all squared. 2 cubed is of course 8 minus 10 times 2 to the x plus 2 is equal to 0. So what do we see now? We can introduce a new, what's the name? K. So let k equals 2 to the x. Okay. So wherever we see 2 to the x, we put a k. So it's going to be 8 k squared minus 10k plus 2 is equal to 0. That can divide by 2. So 4k squared minus 5k plus 1 is equal to 0. Trinomial. So 4k, k, 1 and 1, both negative. So k is a quarter, or k is equal to 1. Do I stop there? No. So what do I do now? We know that k is actually 2 to the x. So that simply becomes 2 to the x is equal to quarter, or 2 to the x is equal to 1. So 2 to the x is equal to 1 can be written as 2 to the 0, therefore x is equal to 0. It is 1. On the other hand, 4 can be written as 2 squared. Bring it up, becomes 2 to the minus 2. Therefore x is negative 2. Okay. I think I should have given you 5, the people 5 marks there. They were robbed with 1. In question 3.1, we are told that find a formula for the general term of the following sequence. So if you look at the top, that forms 1. The numerators all form one sequence, not so. So I got here 1, 3, 5, 7. And the denominator forms a different sequence. 2, 4, 6, 8, and so on. So the general term for this is simple. It's going to be Tn is equal to 2n minus 1. You all agree with that? However, the denominator, this one, what's happening here? I'm multiplying this by 2 all the time. Not so. So if I'm multiplying it by 2, it forms what we call a geometric pattern. For geometric patterns, it follows a formula Tn is equal to AR n minus 1. What's my A value? The first term. A is always the first term, no? Yes? Is it plus 2? Right, you're absolutely correct. Yo. Somebody asked me a question yesterday about geometric patterns.
Oh, yeah, it actually
is it coming? Okay, so I thought this was it. Sorry, man, my mistake. So in the denominator, it's just 1 more than the numerator, not so. So it's going to be Tn equals 2n minus 1 plus 1, which is 2n. So we got the denominator and the numerator together makes this pattern. So therefore Tn is equal to, in the numerator, we got 2n minus 1 and 2n in the denominator. So that's what we're looking at. We're looking for there. Okay? Sorry about that thing. The next one is this one. Yeah. So here, how do you move from one to the next? We say, okay, we're actually subtracting 10. Are we subtracting 10 there? No. So that is not arithmetic. If it was subtracting 10, how much did we subtract there? Would we get a constant second difference? No. Okay? So it's not quadratic either. So if you're looking at this here, we note, okay, it's actually term 2 divided by term 1. So that's negative 4 over 6, which is negative 2 over 3. Then let's test for term 3 over T2, which is 2 and 2/3 over negative 4. So if we put that in a calculator, shift that fraction is going to be 2 and 2 over 3 must be divided by negative 4. What's going on? Divided by negative 4, that gives us 2. Why am I saying 5? Gives you negative 2 over 3. Not so. So what do you notice? You get from term 1 to the next are multiplied by negative 2 over 3. Multiplied by negative 2. So it's never that you divide it by any number. It's always that you multiply it by a certain ratio. So that said, the general form of a geometric pattern is Tn is equal to AR n minus 1. Where A is your first term, R is your common ratio. Your constant ratio, your common ratio actually, which is T3 over T2 is equal to T2 over T2. Okay. So your general term is Tn is equal to, your first term is 6, your R is negative 2 over 3 raised to the n minus 1. Do not multiply the 6 and negative 2 over 3 at that point because of the variable exponent there. Okay. The next question, we are told that a rubber ball is bounced from a height of 4 meters and bounces continuously. Okay, as shown in the diagram. Each successive bounce reaches a height that is half of its previous height. Okay. So if the ball is dropped from 4 meters, then this is going to be, what will this be? If it's half its height, people, 2 years. That's going to be 2. And this, 1. And this, half, and so on. Not so. We are told that if the pattern of the maximum height reached during each successive bounce continues, if the pattern of the maximum height reached during each bounce continues, what maximum height will the ball reach during the 6th bounce? So in the first bounce, so our number pattern actually starts at 2. Can you see it? Bounce 1 is 2, 1, half, and so on. Okay. So it's either you extend this pattern by 6 terms, or we go with the formula. So T6 is equal to A. Can you see you're multiplying it by half here? So it's again a geometric pattern. So it's A R n minus 1, 6 minus 1. So if this is on the calculator, it's 2 times a half to the exponent 5. Gives you 1 over 16th of a meter. 1 over 16th of a meter. Okay. Then the question says in 3.2.2, determine the algebraic expression for the maximum height reached in the nth bounce. So whenever they're talking about an expression, an algebraic expression, then they're referring to the general formula. So Tn is equal to AR n minus 1. I've dealt with the formula now already. There's going to be 2 into a half n minus 1. Now if you simplify this, it could be written as 2 to the minus n plus 1 is 2 to the minus n plus 2. That and this is equivalent answers. But you won't get extra marks if you convert it to that. However, if you make a mistake in conversion, you're going to lose one. Okay? So that day you would have got your full mark at that point already. Then the question in 3.2.3 says, after how many bounces will the ball reach a maximum height of? Is there nothing here? Sorry? It's cut out. Just go to the memo and see what was the... I think this was somebody's paper that they fixed probably over the thing. So, just check there quickly. So it is 1 over 256. So in other words, this is your nth term, your Tnth term. So you got 2 into half n minus 1 is equal to 1 over 256. Okay. So what do I do first? Divide by 2 both sides. So it's going to be half raised to the n minus 1 is equal to 1 over 512. Now if a 512 can be written as 2 to the 9. Not so. So we got the half to the n minus 1 is equal to a half to the exponent 9. So 1 to n exponent remains 1. Therefore, n minus 1 is equal to 9. So n is equal to 10. Okay. Yes? 11.
So if the height is 11, then the fraction should be 1 over 512.
512.
Not 1 and not 1 and
Is that not right here? Sorry?
Yes.
So it should be,
1/512.
yeah. But you saying that this is the answer, that we started. We just see the memo? Is it? 2, 5, 6. Yeah, you see this plus 3 on the memo there. Can you see? Next to the sum. So whoever came to that question, I gave 3 marks. I think I made a mistake here somewhere, man. That's why it was the big stuff. So in a case like this, if there's a mistake from our side, we award the mark. Okay, we give you the, as long as you're attempting the question. Same in the grade 12 exam yesterday. There was a mistake. Tricks nogal. Right, question 4. In question 4, we are told that the given number pattern 0, 4, 10, 18, determine the fifth term of the pattern. So how do I move from one to the next? We're adding 4, then 6, then 8. So adding 2 and 2. So what type of pattern is this? What type of pattern is this? Quadratic. Why? Because it has a second common difference. So T5 is going to be 28. It says derive a formula for the nth term of the pattern. So they're working out the general formula here. Here I 2a, 3a plus b, a plus b plus c. On the bottom up, 4.2. It should now read that 2a is equal to 2, a is equal to 1. So 3 times a, which is 1, plus b is going to be 4. So b is equal to 1. Then we know that a plus b plus c is equal to 0, which means to say that c is minus 2. So Tn is equal to an squared plus bn plus c. So it's going to be a is 1, so it's n squared, b is 1, so it's n minus 2. And it's worth testing if it is correct. So if I test for term 4, 4 squared is 16, plus 4 is 20, minus 2 is 18, which makes the general formula correct. Okay, is it correct? Alright. 4.3, they want to know in 4.3, what is the value of the 100th term of the given pattern? So 4.3, so it's going to be T100 is equal to 100 squared plus 100 minus 2 is 100 squared plus 100 minus 2 gives us an answer of 10,098. Okay. Then in 4.4 says calculate the smallest value of n for which the first term of the sequence will be greater than. So smaller, what's the value for n for which the smallest, now calculate the smallest value for n for which the first term of the sequence will be greater than 20,140. Okay? So the general, the Tn is going to be n squared plus n minus 2 has to be greater than 20,140. So what I'm going to do is I'm going to solve for n here. Take it over the equal sign, it becomes n squared plus n minus 20,142 has to be greater than 0. So it's going to be, you can use your quadratic formula. Don't work out your factors, it's going to take very long unless you can see it. 142. Right, let's take this somewhere. Right, let's see what we get. 141, is that correct? Okay. Normally we get you nice rational values here. I don't know what was wrong with me this day. So this is actually critical values and not values. No? So you got critical values here. and the other one is negative 142, comma 43. So if you look at this graph, that is going to be negative 142, comma 43 and 141, comma 42. Okay, it must be greater than 0. Okay, so the smallest value greater than 141, comma 42 is 142. Okay, we can't go now negative. No? Because what do you want to say? Okay, it's going to tell you here. Okay. So what's the question? The question says calculate the smallest value of n for which, and this therefore T142 is going to be greater than 2014. If they ask you what is the value of the term, then I would have substituted 142 into the general formula to get the value of the 142nd term. Okay? That's a good question. Next. Yeah, then again, all these questions are good. No, some of you will say. Calculate the coordinates of the y-intercept of f. What do you do for y-intercept? X equal to 0. F of 0 is equal to negative 2 over 0 minus 1. Minus 3 is going to give you minus 1. Not so? So the coordinates, so it's going to be 0 and minus 1. The next one says calculate the coordinates of the x-intercept. What do you do for x-intercept? What do you do for x-intercept? So we say x-intercept, let y equal to 0. So you got 0 is equal to negative 2 over x minus 1 minus 3. Take it over the equal sign. So it's 2 over x minus 1 minus equals minus 3. You cross multiply. So you're going to get 2 is equal to minus 3x plus 3. So you got 3x is equal to 1, so x is equal to a third. Is that correct? So the coordinate is going to be 1 over 3 and 0. All okay with that? Right, let's take this out here. Save that. In 5.1.3 we are told that sketch the graphs of f. Supposed to be graph showing clearly the asymptotes and the intercept of the axis. Okay, so this is 5.1.3. So what's the first thing we're drawing? Asymptotes. We have two asymptotes. We have the horizontal asymptote, which is y is equal to minus 3 here, and x is equal to 1. Okay. Then we have your y-intercept is at negative 1 and at a third on your x. Okay, so the graph is going to come through like that. Comes closer to the asymptote but does not touch as I am doing here. You know it's not touching, okay? This comes very close, does not touch the asymptote. Okay, any confusion here? Any confusion? No. No? Move this up a bit. Next question. The question says, the next question says, one of the axes of symmetry of f is a decreasing function. So there's two axes of symmetry. Not some. One is y is equal to x plus c and one is equal to, and the other one is y is equal to minus x plus c. There's two. One is increasing and one is decreasing. So they're speaking specifically about the decreasing function, which is the one that's going through y is equal to minus x plus. Can you see that? Write down the equation of this axis of symmetry. Of course, it's going through the point where the two axes of symmetry, the two asymptotes meet, which is 1 and minus 3. So for 5.1.4, we say y is equal to minus x plus c. We're going to substitute 1 and minus 3. That's an x and a y. So negative 3 is equal to negative 1 plus c. So c is negative 2. Y is equal to minus x minus 2. Okay. And the next question says, write down the domain of h of x. If h of x equal to f of x minus 3 plus 4. So firstly, what is the domain? What is the domain of f of x? What is domain firstly? All possible x value. So what is the domain as it stands here? X is an element. All real numbers, yes. And x cannot be equal to 1. But what effect does this minus 3 have on this graph? Solution of this graph, 3 units to the right. It's always the additive inverse, no? On the x. So if this is x cannot be equal to 1, and I move this x, not the x, the axis of, no, not the axis, the asymptote. Then mal here already, no? We take the asymptote and also move it 3 units to the right. Then it's going to read x is equal to 4. Not so. Then you're going to shift the graph 4 units up. Would that affect your the asymptote, your vertical asymptote here? No, it will stay at x equal to 4. Not so. So my domain there is x is an element of all real numbers. X is just not equal to 4. Okay. But just the trick there, you read it from the current graph given to you. Okay. Yeah, here's the next one. Yes? Sorry? 2. Yeah, x cannot be equal to 2.
Yeah. Because if you calculate h of x, right? And then you say negative 2, and then you put x minus 3 in brackets, right?
Okay, so okay, I know what you're saying. So just give me that equation there quickly.
It's negative 2.
So you got f of x is equal to negative, the normal the function given.
Oh, but negative 2.
Negative 2 over
X minus 1.
x minus 1
And
minus 3. No, that's the equation given. Now if you're going to go with h of x, which is f of x minus 3 plus 4. So wherever we see an x, we replace it with x minus 3. So it's x minus 3 minus 1 plus 4. So that is this part. No. Minus 3. That is that part now. Not so. Plus 4. So this equation is negative 2 over x minus 4 plus 1. So the equation of the asymptote is x is equal to 4 and not 2. Okay. That's another way of looking at the same thing there. Okay. The next question is question 5.2. The following graph of g of x equal to a times b to the x, where a is not equal to 0. P is 2 and 144 lies on f. Okay. Supposed to have been on G. My mistake there. Sorry about that. The question says, and another thing is this is in the same question, so we don't tend to use if twice in the same question. Okay. I probably made the change when I was doing the memo, but can you see I put G, but I put F there. But that wouldn't affect anything. Okay. So the question says you must calculate or prove that whatever. Or here they say if b is equal to 3 over 4, calculate the value of a. So what is the equation of g of x? g of x is equal to a times b to the x. Not so? But they told you that b is 3 over 4. So the equation now reads g of x is equal to a times 3 over 4x. And then I substitute b, which is 2 and 144. So that's going to be 144 is equal to a times 3 over 4 squared. So 3 over 4 is 9 over 16. I divide both sides by 9 over 16. So that cancels. So a is equal to 144 divided by 9 over 16. Okay, it's 256. Is that correct? 256. That's your value for. Okay. B, for number 2, sorry. 5.2.2 ends, write down the equation of g of x. So g of x would be equal to a, which is 256, times b, which is 3 over 4 raised to x. Of course you can simplify this, but I would leave it just like that. The next question says, determine correct to two decimal places. So in 5.2.3, determine correct to two decimal places the value of g of 13. So wherever I see x, I put a 13. So it's 256 times 3 over 4 raised to the exponent 13. Please do not do this in your head. 256 open brackets 3 over 4 raised to the exponent 13. So that gives us 6 comma over 8. Okay. And the question 5.2.4, give the equation of k, the reflection of g in the y-axis. So if something reflected in the y-axis, what happens? X becomes negative. So you say y is equal to 256 times 3 over 4 raised to the minus x. And this is the equation of k of x. Or you can have written it as k of x is equal to 256 into 4 over 3 raised to x. Well, this is accepted. Okay. People, for tomorrow, inshallah, we're going to conclude this paper. And you guys can start with paper 2. Maybe during tomorrow's lesson, we will touch on the first few questions of paper 2. People enjoy the rest of your day. Good morning, class.